Hey, welcome. Some of you, welcome back to the 2012 practice AP Calculus AB exam. College Board put this out about a decade ago. We are going to start Section 1, Part B. All right, we put up 3 videos that took care of all of Section 1, Part A. Those are done. You can go back and look at those if you want. We're going to cover the first 9 questions, questions 76 through 84, and glory be, we get to use a calculator. Okay, 2 things that I always say, and 2 things that I'm going to add that I don't normally always say. And the 2 things that I say are follow me, because that helps you with getting notifications when I put up new content. Okay, so follow me. Like the video, because that helps me. All right, and while you're down there, throw in a comment before you say anything. My previous videos weren't allowing comments. I've changed all that. You can allow comments now. How come? Because I was making these videos for children, meaning high school children, and young adults in college also, or hey, older adults. But the main focus was secondary students in high school and maybe younger college students. All right? But I didn't realize that when I mark it for kids or children, you can't put comments. I've changed all that. You can put comments down, and if you want to see me do a test, throw it in the comments, please. All right? And I'm excited to tell you that I put up a how to solve a Rubik's Cube video. I know how to solve one, and students always ask me how to solve them. Boom. So check out my channel, and you can catch that video if you're interested. And finally, I get so many questions about what type of calculator should I use? What type of calculator should I use? What type of calculator are you using, Visca? I use the TI-84 plus CE. That gives me the colored lines, all right, when I graph them, I can pick any different colored lines. It's a lot cleaner, and they're chargeable instead of putting batteries in it. I love them. And I'm putting links to the most popular colors in the description of this video. Any video where I use a calculator, I will now put the links to those because people ask me all the time which ones they are. All right? Whew! That was more than I normally talk. Let's get started. Number 76. The graph of the function f is shown in the figure above. Okay? For which of the following values of x is f prime of x positive and increasing? All right? Okay, so I have f, and you know how much I love tables and graphs and charts. Fantastic. This is f. They're asking me about f prime. That's the slope of f. Okay, that's the whole purpose behind this question. Okay, so when is the slope of f, or f prime, positive? That means I have an increasing slope. Okay, let's look at that first. Increasing here to here, and increasing here to here. Okay, these are increasing slopes. All right, this is a negative slope here, so I don't want that. This is a negative slope here, I don't want that. All right, and when is the slope of f, okay, the first derivative of f increasing? Okay, that means the slope is actually increasing. That means the second derivative is positive. Okay, that means it's concave up. Okay, this is a sad face. This is a happy face. So it looks like at point E is the only point where that happens. 77. Let f be a function that is continuous on the closed interval inclusively between 2 to 4, with f of 2 being 10 and f of 4 being 20. Which of the following is guaranteed by the intermediate value theorem? Guaranteed by the intermediate value theorem. Okay, train your brain. These are coordinates. First thing I'm going to do is I'm going to plot these because we like visuals. Okay, we're going to go 1, 2, 3, 4. Those are our 2 x values at 2 and 4. We'll go 5, 10, 15, 20. Okay, 5, 10, 15. Because we need both of our y's at 2, 10. So at 2, 10, that's right here. And at 420, anyways, 420, there you go. All right, those are two coordinates. So what is guaranteed? Well, the definition tells me, the intermediate value theorem states, all right, that there is some value in C that has a y value or a solution between two coordinates if the function is continuous, okay? If the function is continuous. And it's continuous. Meaning if I connected these two dots, it doesn't matter how I connect them, okay? Let's, in fact, before we even do that, f of 13 has at least one solution. Let's make sure we're using this thinner one here. 13 is right here, okay? F of x equals 13. Sorry the way I said that. There's some x value with the y value is 13. So my y is 13. So at this line right here, it's guaranteed to have at least one solution. That's the answer. This is what's guaranteed. How come? All right, well, there is no way I can start at 210 and make it to 420 without passing this orange dashed line at least once. Okay, that's why it says at least one. I mean, what if I went like this, then this, then this, then that? Hey, at least once. You've got to cross 13 at least once. And there you go. Okay, what about B? B says f of 3 is 15. That's a coordinate. I don't know where 3 is. I mean, 3 might be 13. Look at, here's 3. It might be 13 here, but on the blue line, that's definitely not 13. It's up here. That's not guaranteed. Okay, and none of those are guaranteed except A, which is the intermediate value theorem. The intermediate value theorem. Okay, now you might say, what about this one here? That's the, what's that, for the intermediate value theorem for the first derivatives when the change in y over change in x is equal to the derivative at some point, okay? That's not the intermediate value theorem, okay? That's the specifics here. Hey, finally a question we get to use the calculator. I can tell just by looking at those responses, 3 decimals, okay? 78 reads, the graph of y equals tan x, or excuse me, y equals e raised to the tan of x minus 2 crosses the x-axis at one point in the interval from 0 to 1. What is the slope of the graph at this point? Okay, first of all, I need to see, well, what x value, okay, what x value do I have that would make that be a 0 or an x-intercept, okay? And next, all right, I need to find the derivative or slope at that point. So I need to find the derivative at my x value that I'm trying to find. So first, let's open up this calculator, view attached to LCD, and we are going to put in the equation that they gave us because we want to find the x-intercept. All right, let's go to y equals. We have e raised to the tan of x minus 2. So pop off that exponent before you put your minus 2. If I graph this, and again, my interval is between 0 and 1. Okay, so it crosses at several points, but right there, that last one that was drawn, this is the one between 0 and 1, right there. And I don't know, this mic keeps on getting closer and closer to my face. I don't know what's up with it today. So let's change my window. Okay, x I want between 0 and 1. I don't care about anything else. So let's just go from -3 to 3, just for poops and giggles. Just so we can really zoom in on there. Okay? Oh, that would have been really amazing if it would have been the same spot as when it was zoomed out. So I need to find this spot right here. Okay? I got to find that x value. What x value is that? All right, well, okay, there you go. We will say second trace, and I want the 0. Let's go here, do the left bound, and then we got to come up here and do the right bound, hit enter, and hit enter one more time. Okay, that's an x value of 0.6061, whatever. You can see down here, that is currently stored in my x. All right, so what I'm going to do, I'm going to quit this thing here, and I'm going to take my x value, I'm going to store that into, I don't know, a. How about that? Store an a. So anytime I use a, it's there. Yes, you could have used x, but you'll see when I use the derivative function, I don't like making x equal to x. It gets weird. Okay? So now, we said that's about 0.6061, da, da, da. I need to find the derivative at 0.6061, da, 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 da. Why don't I just use the calculator? I'm going to use the calculator, kids, because I can. So I'm going to go to math 8. That's my derivative function. I want to find the derivative of e raised to the tan of x. Okay, put the parentheses the right way. Pop off that minus 2. I want to take the derivative of that when x equals a. This is why I don't like to say when x equals x right here. I don't. It's just a little thing I got. Okay, I hit enter and I get 2.96. That would round to a 1. This 0 would round up because that is 5 or bigger. Bam. So this was completely done in the calculator, and that answer is choice D. Now, again, people ask me all the time, if you fast forwarded through the intro, what calculator do I use? That has those different colors, that sets up the fractions all nice, that's rechargeable. It's the TI-84 Plus CE. All right, I put links to all the sweet colors in the description below, so if you want to, you can check those out on Amazon. I mean, of course, where else are you going to get them? All right, so check that out. I also have a link to a case that I use. I have the mint green one. I love it. It's sick. It's sweet. All right, here we go. 79. A particle moves along the x-axis. The velocity of the particle is given at time t. The velocity of the particle at time t is given by v of t. And I start switching words around. It gets crazy. And the acceleration of the particle at time t is given by a of t. All right? Which of the following gives the average velocity of the particle from time t to time t equals 0 to time t equals 8? My God, I need more coffee. A coworker just told me if you download the app from Dunkin' Donuts, every Monday, whatever you buy, they give you free medium coffee. I think I need to go get some like little donut holes and whatever they call them. Oh, that's my own at-home coffee. And I need to drink more coffee. And so here we go. Anytime I want the average value of anything, including velocity, if I have acceleration, remember, that's the derivative of velocity, which means if I go backward, that's the integral. So if I integrate acceleration, that gives me velocity. Don't forget, you need to put your dummy variables there. But anytime I want the average of this, whatever my upper bound and lower bound are, in this case from 0 to 8, I need to do one of two things. I either need to divide by that difference, 8 minus 0, or in the case of most of your textbooks, instead of dividing by that, they multiply by 1 over that. This, my friends, is the definition of the average value when you integrate. That is choice B. We've done 4 questions, and we've had to use the calculator once. All right, now we have 5 more questions, so maybe we'll use it more there. But that's how these tests roll, kids. And here is another question that you do not need a calculator for. All right, maybe the back half, the next 8 questions after this video. Number 80, the graph of f prime, the derivative of f, is shown, well, in this case, I made it below. On your test, it says above, and it's above, but I liked it below. So this is the graph of f prime. So I immediately make my y f prime of x. Or, I mean, I guess what I can do is I can say my y equals f prime. Okay, so whatever y value of any of these points are, that would also be the derivative of f, that y value. Okay, so which of the following statements must be true? Must be true. Okay, f has a relative minimum at -3. Here's a -3 right here. I am going from a negative y value to a positive y value. Okay, so that means my f has a negative slope when it gets to -3, then goes to a positive slope. Yes, that is a minimum. That's true. All right? The graph of f has a point of inflection at x equals -2. Here's -2. No, a point of inflection would be the second derivative not only would equal 0, but it would change concavity. It would go from positive to negative, or negative to positive, all right? If I'm looking at this, the second derivative is the slope of the first derivative, right? The first derivative has a positive slope here, 0, but then stays positive. So it does not switch. That is false, all right? So the graph, let's look at 3 here. So I know 2 can't be in the answer. Doo-doosh, doo-doosh. Okay, so it's either 1. Well, it can't just only be 3, because we know 1 is true. So it's either 1 or it's 1 and 3. So it's either A or E. Let's clean this up a little bit. Go here. I love the calligraphy pen. You know I do. The graph of f is concave down from 0 to 4. Again, concave down means the second derivative is negative. Second derivative means the slope of the first derivative, which is what we have. It should be a downward slope from 0 to 4. Here's 0, 1, 2, 3, and here's 4. So it's decreasing this whole time, and that is absolutely true. So 1 and 3 is the answer, which is choice E. 81. It says we're going pretty quick with this, considering I took an extra like 45 seconds in the intro. But there were some things that I had to discuss about the comments and other videos and links that I've put up here. So that was needed. Anyways, 81. A water. Now, how about I drink a coffee right now? I promise I'll be better, children. Water is pumped into a tank at a rate of R of t, which is 30 times 1 minus e raised to the negative 0.16 t, and that, my friends, is in gallons per minute, where t is the number of minutes since the pump was turned on. If the tank contained 800 gallons of water when the pump was turned on, how much water to the nearest gallon is in the tank after 20 minutes? All right, here we go. This is my rate. Whenever I have a rate, in this case it's gallons per minute, okay? If I take the derivative of it, I go gallons per minute squared, okay? I would start with gallons, and when I take the derivative, that gives me my rate. They want to know to the nearest gallon, okay, how much water's in there. So they want this. I have the rate. I need to integrate to go back. Okay, so that's the first thing. Okay, I need to integrate to go back. The second thing, which is pretty important as well, calligraphy. I wish by default, I gotta learn to make that by default. The second thing is, there's 800 gallons of water in the pump when it was turned on. This rate represents the gallons per minute since the pump was turned on. So when I integrate my rate, yeah, that's a DT. Ha, ha, ha. Oh, hold yourself to a higher standard, Visca. And I got to drink stronger coffee. Okay, DT. Okay. 20 minutes. So starting this is when I turned it on at time 0 to 20 minutes. Okay. This would give me how much water gets added into the tank then. But don't forget, there was already 800 in there. So I need to add that. So there's no way I can have less than 800 in there because there was already 800 in. I guarantee you what, if I did not add 800, if I just figured out what number this is, that answer will definitely be here somewhere if you forget to add the 800. Okay, so let's go ahead and use our calculator. Hey, the second time we get to use this beautiful piece of machinery. And I'm going to integrate. Okay, math 9. 30, parenthesis, 1 minus e. Oh, I didn't do my bounds. Math 9. Goodness gracious, from 0 to 20. There we go. 30 parenthesis 1 minus e to the negative 0.16 x, pop down, parenthesis again, because we have two openings, we need two closing parentheses, dx. I guarantee you right now, without adding the 800, 420 is there. And that's choice B. Look at that. That is choice B. But I need to take 800 and add it to this answer right here, because 800 gallons were already in there. So I should have 1,220 gallons. That's rounded to the nearest whole number, the nearest gallon, 1,220. So this, my friends, is 1,220 point, I don't know, it was 1.4 or something. I don't know what that was. But 1,220 gallons. Choice D. If you know what you're doing in the calculator, some of these problems, I mean, what did I take? A couple minutes to explain it? Should probably taken you 15 seconds to put it in a calculator if you know what you're doing. 82. If f prime of x is equal to the square root of x to the fourth plus 1 plus x cubed minus 3x, then f has a local minimum, a maximum, at x equals which of the following values? Calculator problem. Look at all these responses. All right, first of all, calligraphy pen. Second of all, what's that, like a blue-gray? That's nice. Okay, so first derivative, local maximum. In order to find a maximum, my first derivative needs to go from positive to negative, because I need to climb, then decrease, okay? So, but I don't have a graph of f, I have a graph of f prime. So I'm just going to look to when my first derivative value is positive and when it goes to negative through the x-axis. What do I mean? Well, let's graph this first, okay? So let's bring up our calculator again. Let's go to y equals. I love all these colors. You know what? I'm going to use green. It's my favorite color. So you know what? That's what I'm using. Square root of x to the fourth plus 1. Pop out of that square root, then add x cubed. Pop off of that exponent, minus 3x. You would be surprised at the number of students that get this wrong because they're not popping out of functions. All right? And let's go zoom. Let's make it a standard 10 by 10 window. Where are you? I'm so sorry. Okay, here we go. That's our graph of f prime. Let's bring this out here. Go here, bring this up, go here, bang, da 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 da. All right, this is f prime, okay? Remember, I want to know where f prime goes from positive to negative, okay? So anytime my graph is above the x-axis, it's considered positive up here. Anytime my graph is below the x-axis, it's considered negative. How come? Because this fantastic line right here is where y is 0. That's where y equals 0. Remember, y is my first derivative. Okay, and any y values down here are negative y values, aren't they? And my y is my first derivative. So let's see where I go from positive to negative. All right, negative y values here. 0 right here. Positive y values here. Okay, that's not, well, it's not. This is negative to positive. I want positive to negative. Okay, positive here, and then ooh, this little dip right here. It's negative, negative, negative. Then it goes back to positive, 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 positive. So we actually have 2 points here and here. Okay. In fact, I should probably zoom in because that's tough to see. Oh, I'm so sorry, guys. And I'm going to use zoom box here. Zoom box, enter. Go here, go up. Ooh. Hit enter. Dip, 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 right there. All right. Using our same mentality with anything above the x-axis, that is a lot more clear to see. Okay, anything above the x-axis is positive, and anything below the x-axis is negative. Positive, positive, positive. And this is also above, okay? This was below, so these are negative y values, and our y is our first derivative. Zeros are right here. So as I go left to right, which point goes from positive to negative, right here? This one goes negative to positive. This one goes down, then up. This one here has a slope that goes up, then down. That's my maximum. So I need to find out that x-intercept right here, okay? So messy. So I go second, trace, and I find my 0. I can't tell you, I teach this skill, these calculator skills in Algebra 2, and I tell them that you're going to need to know these for calculus. It's going to help you with so many things. Enter, and that's 0.350. 0.350. C. There you go. Down to the final 2 questions. The final 2 questions. And here we go. Man, I should be an announcer. 83 reads, the graph above, love me some graphs, gives the velocity in feet per second of a car for t values between 0 and 8 inclusive, meaning it includes 0 and 8, where t is the time in seconds. Of the following, which is the best estimate of the distance traveled by the car from time 0 until the car comes to a complete stop? Okay, first of all, the car comes to a stop when my velocity is 0. That's here. Velocity is 10, 20. Those aren't negatives. I'm just marking them. 10, 20, 30. Here's where velocity is 0. So it stops right here. So from 0 to 8. The best estimate of the distance traveled. Distance would be in feet because velocity is feet per second. If velocity is feet per second, distance would just be feet. Velocity is the derivative of distance or position. That means I need to integrate to get position or velocity, or go from feet per second to just feet. I need to integrate. Integration, my friends, is area under the curve. And I don't have to be exact. I just need to estimate the area under the curve. Here's where your issue happens. Each one of these blocks right here. Okay, yeah, okay, that was nice. It went completely away. How about we just do that? Each one of those blocks isn't an area of 1. It's 1 by 10. What do you mean, Visca? The distance from here to here is 1. The distance from here to here is 10. So each one of those blocks is 10. So I'm not adding 1. So I can add them all together in 1 and then multiply by 10 if I want. Okay? Or I can just add up all these 10s. Okay? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160. I mean, these two add up to almost 1. It's 170. This is almost 1. 180 with this. This is 190. I don't know. This is almost 1. 200. This is kind of... Yeah, almost 1, 2, what do we get? 210, right about 210? Yeah. So there are approximately, if I add up approximately 21 squares, and each one of those squares is an area of 10. I just added by 10s, but you can do that, and you should end up with 210. This is an approximation. It doesn't have to be exact, okay? Area under the curve. It's testing you on whether you know, first of all, when you have velocity, we want to know distance, you need to integrate. And second of all, integration is area under the curve. 84. The last one, and we're done with this video, thank God. 84 reads, for an x value between negative 1.5 and 1.5, let f be a function with the first derivative given by f prime of x equals e raised to the x to the fourth minus 2x squared plus 1 minus 2. Which of the following are all intervals on which the graph of f is concave down. Calculator problem, because look at all those responses. So let's break down what we need to do to solve this last and final question. Oh, great. Okay, they want to know the intervals on which the graph is concave down. That means my second derivative is negative. Okay, second derivative is the slope of the first derivative, and that's what they give us. So I need to take a look at this graph and look at the slope, and I want to know where it has a negative slope. On what intervals does it have a negative slope? And that's really it. And thank God we get to use a calculator, because that's going to make life so much easier. Turn this on, go to y equals. Oh, Mr. Greenie, I love you so much. Let's clear that out. Let's go back up here to blue. And I'm going to put in e raised to the x to the fourth. It's a heck of an exponent. Minus 2x squared plus 1. I need to pop off that exponent and subtract 2. Let's go to zoom and go back to a standard 10 by 10 window. That's choice 6. And okay. So where do I have a negative slope? First of all, this whole thing is negative. This is a negative slope until I hit this point right here. Okay? And then I got another negative slope from this point to this point. Okay? This slope is considered positive, and this is considered positive. So I need to figure out, okay, so I'm going from negative infinity all the way to this point here. And then I go from this point, from this point to this point. So I've got to find all three of those. Okay, so let's zoom in. Let's zoom in. And it might be a little bit easier. Let's do our box, because you know I love me to box. Go over here. Hit enter to start my box. Scroll up. Scroll over. Boom. Let's do this. Okay. All right. Oh, this is going to be nice. Okay, so go to second trace, and I want to find the minimum. Okay, so I want to find the minimum point right here. So I go here, hit enter, go to the right, hit enter, and hit enter one more time. That x value is -1. So remember, we're only going to -1.5. That's our intervals. It tells us when we start the problem. So from -1.5 to -1, that's one of my intervals. Okay? This other interval happens to be right here. That's at 0 on the x. And then we got to go right to here, which looks like it's at 1, but let's check that. Let's check that just to be safe. Second trace, find the maximum. We'll do the 0 first. There we go. Hit enter. I want the maximum between this 2 points. It should be 0. And it is. I moved that over 6 times. 0.5 zeros and a 1. Okay. Second trace. And let's find the last minimum here. My minimum is going to be between here and here. And that is 1. So the two intervals where I have a negative slope, okay, where I have a negative slope of this, which means a negative second derivative, which means concave down, was from -1.5 to -1, and then from 0 to 1. And that is choice D. We are done. Thank you. Follow me. That helps you. Like the video. That helps me. Comment. I will take requests on what I do next. Check out that solving YouTube video, and check out the links for the calculators that I use. They're incredible. I'll see you for the second video for section 1, part B. Adios.